Good day, grade 10th. Welcome to the maths session on analytical geometry with myself, Mr. Nombewu. So this session or this lesson is dated for the 6th April 2020, which is Monday. So I hope you are going to enjoy the lesson and also get your stuff in order, like your writing book, your calculator, as well as your textbook next to you, so that whatever content that will be covered here today, you can be able to highlight it on your textbook. All right? So we are doing analytical geometry. Remember, the word geometry involves shapes. Okay? And then another thing is this concept or topic is also called coordinate geometry, okay? Because we are dealing mostly with points, all right? Your XY coordinates. Now let us start with our lesson on analytical geometry. So the first thing that I want us to look at is the lesson objectives, okay? So we'll be covering distance between 2 points. We'll be covering gradient of line segments between 2 points, any given points. We'll be also covering gradients where we have parallel lines or lines parallel to the y-axis or the x-axis. We'll look at gradients that are perpendicular to the y-axis or the x-axis of a Cartesian plane, and we'll look at what we call collinear points. As a grade 10, you need to know what is it that we mean when we talk of collinear points. All right. Number 4, for our lesson, we'll focus on midpoints of line segments. Okay. So the word mid comes from middle. So a middle point obviously should be a point halfway between 2 points. Okay. Then last part of the session, we will look at how to determine an equation of a straight line. Okay. Now let us go to our slide number 4 and start with our lesson. All right. So imagine that we have a straight line, and on a straight line we have 2 points. Okay, point A and B. Then I ask you, what is the length of AB? Okay. Imagine that you are standing next to a tree, and then you are a few meters away from home. Okay. If you are to join the point where you are and the point at home, then you can be able to determine how far you are, obviously using what we call displacement, those who are doing physics, and then it will tell you how far the length of the 2 points from where you are and how much length you need to cover in order to get home. Okay, so that is distance between 2 points, and when you talk about distance between 2 points, you can also refer that to length of a line segment. Okay, so I will either use the term distance or length of a line segment, okay, between 2 points. Now, having said that, how do we find this length or distance between 2 points? We use what we call the distance formula. Okay, there's nothing fancy about this. Distance formula is just a formula that we use to find the length of the distance between 2 points. Okay, and the formula is d equals to square root of x minus x1, so that's x2 minus x1 all squared, plus y2 minus y1 all squared. Okay, where d is the distance, okay, between the 2 points. And then when we calculate the length of the distance between 2 points, obviously, what is the most important thing? If I ask you from your home to school using displacement, how far do you travel? Then you cannot say to me, you are traveling 10, okay, or you are traveling 50. There are supposed to be units, okay, 10 meters, 50 kilometers, etc., etc. So when we deal with distance formula, we are saying units are very, very important. Meters, millimeters, centimeters, kilometers, etc. Okay. In the case where you are not given units, you can or you are allowed to use the word units. Okay. For example, let's say I'm calculating the distance between point A and B, and then I find that my answer is 5. Okay. You don't just leave it as 5. You're supposed to say 5 units, unless there are units given. Okay. Then let us talk about running off. Remember, sometimes you'll find answers that are simplified. Okay. But at times again, you'll find your irrational answers. Okay. So irrational answers are your surds. Okay. So if you're finding an irrational answer or a surd, sometimes or most of the time, in the instruction and information, you will be told to round off to a certain number of degrees. Okay. So either you'll be told to round off to 2 decimal places or 10, whatever, 4 decimal places, 2 decimal, 1 decimal place. It depends on the question paper that you'll be having at that particular time. Okay. Obviously, most of the time it's just 2 decimal unless stated otherwise. Okay. So you need to punch in your calculator SD, which will then give you decimal form of your answer. Then you round off according to the instruction. Now, another thing is you'll find that we say calculate the length of AB or DC or whatsoever, and then we say leave your answer in the simplest set form. What is the simplest set form? We are just saying do not write your answer in decimal form. Leave it as a surd or as an irrational number. Okay, do not change it to decimal form. Very important. That is about the distance between 2 points. Okay, and then now we want to move on to slide number 6. Let us look at this. Remember, the distance formula on its own is d equals to square root of x2 minus x1 all squared plus y2 minus, that is x2 minus x1 all squared plus y2 minus y1 all squared. Then the whole thing, you take the square root, right? But what if I am to square both sides? But remember, d equals to square root da da da. And if I'm squaring both sides, then of course on the left hand side I'll be getting d squared equal to, what happens with the square root? If you square it, it is gone. Okay. As a result, I'll be left with bracket x2 minus x1 all squared plus y2 minus y1 all squared. Okay. So this is just to say, if you are to find any of the coordinates there, either x1, x2, y2, y1, then you will have to first get rid of the square root. Okay. So this will be the simplified equation where you need to find a particular coordinate. Good. Now let's look at as an example where you have to use your distance formula. Example 1, given the points A, which is 3 minus 2, B minus 5, 4, determine the length, underline length. What am I looking for? I'm looking for the distance between 2 points, the length of line segment AB. Okay, first thing that I do, I write down A and B and their points. Then I start telling the examiner or the marker which one will be my x1, x2, which one will be my y1, y2. Okay, now using the distance formula, obviously, what is my d now? It's AB equals to square root of, you still write the original formula first. Please don't just substitute straight away. Start by writing your original formula. Okay, sometimes it has a mark. Actually, most of the time it has a mark, so you may lose a mark if you don't start by writing the formula. Square root x2 minus x1 all squared plus y2 minus y1 all squared. Okay, and then substitution. This is just direct substitution. When you substitute, then we find out the distance between point A and B, or the length of AB, is 10. Look at what I've done. I've written my answer in red and then something in black to show you that units are very, very important. Okay, that was example number 1. Let's go to example number 2. Now, in example number 2, we are given the points A, which is 4, 10, B, minus 3, minus 8, and the question is determine the length of line segment AB. Okay, we are more or less doing the same thing like the previous question. Give your answer correct to 1 decimal place. Okay, sometimes I may say to you, leave your answer in the simplest set form. Okay, so it will depend, but in this case we are rounding off to 1 decimal place. So I write down first my A, my B, then I allocate x1, y1 to A, x2, y2 to B. Okay, and then I use my distance formula. Remember, I'm finding the length of line segment AB, so that is the distance formula problem. What did I say? We start by writing the original equation or formula. Okay, and we substitute. Then I found that my length of AB is square root 373, of which I can't leave my answer like that. You remember why? Because we were told to correct to 1 decimal place. Therefore, I punch my SD in the calculator and I found that AB is 19,3 units. All right. Well done. Now, let's go to slide number 8. We have another example now, example 3. We're still on the distance between 2 points. Now, what is happening here? We are given the point P, which is minus 5, 6, and Q, which is minus 9, Y. And the question is determine the values of Y. If PQ is 5 centimeter now, in this problem, we are given the length between point P and Q, which is the length of PQ, and it's 5 centimeter. Okay, that is length. And then we are actually not having the Y coordinate of Q, and the question is asking for that. Now, what do? We first write down P and Q. Then for P, we get x1, y1. For Q, we get x2, y2, where y2 is our unknown y. Now, we still write down the distance formula. PQ equals to square root x2 minus x1 all squared plus y2 minus y1 all squared. Then, what did I say? I said if we have an unknown coordinate that we must find, then we must square both sides. So the simplified form of the length of PQ will be PQ squared equal to x2 minus x1 all squared plus y2 minus y1 all squared. Substituting everything that is given, then we found that y minus 6 is equal to, you see, I wrote in red so that I can tell you why we have a plus or a minus. Okay, so what is happening here is in the step before this one, there's 25 equals to 16 plus y minus 6 all squared. Remember, we're going to transpose the 16. Then we are getting 25 minus 16, which is a 9. So we'll be getting y minus 6 all squared equals to 9, but we get rid of the square so that we can get to y, right? So when I introduce a square root, then I must also introduce a plus or a minus, because I have 2 possible solutions. Okay, therefore we get y minus 6 equals to 3, or y minus 6 equals to negative 3. The plus or minus comes from introducing a square root. Therefore, when you work with those separately, the value of y is equals to 9, or y is equals to 3. Those are the 2 solutions that we have got. Now, slide number 9. We are going to the second part of the lesson. And what is it about? Gradient. We are going to ask you about gradients in your exam. And beside exams, you also need to know what is all about gradients. Okay, I hear this word gradient most often. Sometimes we don't call it a gradient, we call it a slope of a line. I think that's the most nicest name or term that we can use when we start talking about gradients. Slope. What's a slope? Slope is about the steepness of a line. Okay. For an example, let's say you have a table. Okay, you put an object on the table and then you start lifting up the table. What happens? You see that the object starts to slide on the surface of the table. Okay, but as you lift the table up and up and up and up and up and more upper, then the object slides even more faster. What does it mean? It means the steepness of the table is increasing, or the steepness of the surface of the table is becoming more and more greater than it was before. Okay, so in our maths, what are we saying? We are saying that is what we call the gradient. Okay, so straight lines have gradients, or they have steepness, and the steepness varies for different lines. Okay, so if you have a straight line, the more closer a straight line is to the y-axis, we then say it has it is more steep than a line which is far away from the y-axis. Okay, so let's look at the notes. We said gradient focuses on the steepness of a line. Okay, and then when we have a very steep line, what does that tell us? It means we have a large, M stands for gradient. We have a large gradient. Okay, and this means that the line is closer to the y-axis. I think I've already said that. If a line is less steep, what does that mean? It means we have a smaller gradient. Okay, and that means the line is far away from the y-axis. That is all about gradient. Okay, so a gradient is about a steepness of a line, and that's it. Now let's go to slide number 10 and check. I've drawn a graph for you on a Cartesian plane. Okay, and my straight line is the red line. Focus on the red line. What do you notice about the red line? The red line is parallel to the y-axis, or perpendicular to the x-axis. And I think I've written that down. Line is parallel to the y-axis, or it's perpendicular. Okay, meaning it forms a 90 with itself and the x-axis. What does this mean? Remember, the x value for that line will remain the same. Whatever happens, we have only one x value. But this one x value corresponds with many y values. So what does that mean? It means change in y will remain as change in y. Remember, change in y will be 2 points. When you take the difference of 2 points, all over. What is change in x? Change in x, there's no change in x. So 0, nothing. Nothing is changing. As a result, what do we know from grade 8? Division by 0 yields an undefined. So this means that the gradient of a perpendicular line to the x-axis or parallel to the y-axis will have a gradient that is undefined. Okay, now on this slide now, what is it that we are seeing? We are seeing that our red line, straight line, is actually closer to the y-axis. Okay, so since the red line is closer to the y-axis, what does it mean? That means the change in y will be bigger compared to the change in x. So change in x will be smaller. When you take the ratio of the two, change in y over change in x, obviously if you have a big number over a small number, the answer will be big. All right, and as a result, this means we have a greater gradient, a bigger gradient. Okay, this line will be very, very steep. Okay. However, when this red line now is far away from the y-axis, what does it mean? it means it is increasing faster along the x than along the y-axis. That means change in y will be small and change in x will be big. And when you take the ratio of the two, change in y over change in x, then we are getting a very small answer. Because if you have a small number divided by a big number, the answer will always be small. Okay, that then means the gradient of a line that is far away from the y-axis will be very, very small, and that line will be less steeper. Okay, this is very important, and this is all about gradients. Okay, now let us look at the relationship between delta y and delta x, or change in y over change in x. What is this? We just spoken about it. We said it's the gradient. So m is equal to change in y over change in x, where change in y will be y2 minus y1 over x2 minus x1. Okay, this is the formula we use to calculate the steepness of any straight line, the gradient of any straight line. Okay, now let's go to the other point which is very important regarding gradients, examinable. Okay, when we have parallel lines, remember these lines will never touch anywhere, anytime. Okay, they will always move at the same pace, at the same steepness everywhere. Okay, so since these two lines have the same steepness, they have the same slope, what does it mean? It means these lines which are parallel to each other will have the same gradient. Note it down. If line AB is parallel to line CD, meaning they have the same steepness, and therefore they will have the same gradient. I hope that is very clear. However, if I have perpendicular lines, okay, please don't confuse these two. Parallel lines equal gradients. Perpendicular lines, what is going to happen? We discover that if lines are perpendicular, for an example, if AB is perpendicular CD, then the product, okay, underline, the product of their gradients, the product of the gradients of the two lines will equal to -1. Okay, let us look at that one. You see, if AB is perpendicular CD, then the gradient of AB multiplied by the gradient of CD will be equals to -1. We will ask you, is line perpendicular to line blah blah blah? The thing that you need to do is multiply their gradients. If the answer is -1, then you can conclude that line whatever is perpendicular to the other line. Okay, now a quick recap. NB, what did we say about a gradient of a horizontal line? We said the gradient will be equals to 0 because the change in y will be 0. Y is not changing. What is changing? X values. So the gradient of any horizontal line means parallel to the x-axis, okay, or perpendicular to the y-axis. Gradient will be 0. Then what about the gradient of a vertical line? Vertical to what? This is perpendicular to the x-axis or parallel to the y-axis. The gradient will be undefined. Why is it undefined? Because there is no change in x. Change in x is 0. Division by 0 is undefined. Okay. Now, moving on, let us look at an example. Example 4 regarding gradients. Remember, up to now we have covered distance between 2 points. Now we are looking at the gradient. Okay. Example 4. Given the points A, 2, 3, B, -5, 1, C, -12, Y, D, 3, minus 3, 10. That is for D. Okay. Determine the value of Y if, meaning we're going to get different Y values looking at each of the statements. Okay, now we are just testing understanding from what we were discussing. Determine the value of Y if B, you see B? If B is the midpoint of AC. I know we haven't covered midpoint, but this is simple. I've tried to do it in a nice way that you can easily understand. Okay, if B is the midpoint of AC, what does it mean? It means the x value of B will be halfway between the x value of A and halfway the value of x for C. So for A, I have 2 for x. Now, then the value of x for B is minus 5. Then the value of x for C is minus 12. But how did we get minus 5? Let's check. We said the x value of A plus the x value of C, which is 2 plus minus 12. Check there in the purple color. Divided by 2. Why 2? Because from 2 to minus 5 and from minus 5 to minus 12, those are 2 segments. Okay, so divided by 2 is equal to, okay, what did you get as an answer? Minus 5. Okay, that means for us to find the x or the y coordinate of the midpoint, we have to take what? The x as well as the y values of the 2 points which the midpoint is lying between. All right. Now, to answer A, B is the midpoint of AC. Okay. What do we do then? We write down the y value, the y coordinate of A, 3, and then we write the y coordinate of C, which is y, and then do we know the y coordinate of the midpoint of AC? Yes, and that is 1. Where do we get the 1? From B, the coordinates of B. So 3 plus y over 2 is equals to, in this case we know the y coordinate of the midpoint, it's 1, and therefore finding y by cross multiplying, 2 times 1 is 2, equal to 3 plus y, transpose 3, we are getting y is equals to minus 1. Good, let's go to B. Determine the value of y if AC is parallel to BD. What do we know if line AC is parallel to line BD? That means the gradient of AC will be equal to the gradient of BD. Okay, let us look into that one. So what is the gradient of AC? Okay, because we don't know what is y, it means the gradient of AC will be in terms of y. This will be y minus 3 all over minus 14. And then, what is the gradient of BD? It will be 9 over 2. I didn't do the calculations here, but I want to believe that you will do them in your practice book. Okay, write down AC, allocate them as x1, y1, x2, y2, as well as BD, allocate them as x1, y1, x2, y2, then use the gradient formula, m equals to y2 minus y1 over x2 minus x1. Then you will find the gradients that I have found here. But what do we remember about AC and BD? Good. AC, BD, parallel lines. Parallel lines have what? Equal gradients. Therefore, y minus 3 over minus 40 is equals to 9 over 2. When you cross multiply, 9 over 2 multiplied by negative 14, then transpose the minus 3, we are getting y equals to negative 60. Okay. Now, let's go to C. Determine the value of y if AB is perpendicular to CD. What do we know if lines are perpendicular to each other? Those lines will have a product of their gradients being equal to minus 1. So the first thing that we need to do is find the gradient of AB, find the gradient of CD, multiply them, equate them to minus 1, and then find the value of y. Alright, let us see. The gradient of AB, remember I didn't do the calculation here, I'm only showing you what the gradient of AB is. Please do the calculation. 1 mark formula, 1 mark substitution, 1 mark answer. If you don't do that, you just write the answer 0 out of 3. Okay. Now the gradient of AB, 2 over 7. Gradient of CD, y minus 10 over minus 9. Remember, we don't know what is y. That is why the gradient of CD is represented in terms of y. Okay. But remember, AB and CD were said to be perpendicular to each other. So perpendicular lines, we multiply their gradients. 2 over 7 multiplied by y minus 10 over minus 9. And I started by dividing by 2 over 7. Okay, both sides. Then I was left with y minus 10 over minus 9, all equals to minus 7 over 2. Okay, minus 1 divided by 2 over 7 gave me minus 7 over 2. Then I cross multiplied minus 7 over 2 times the minus 9 plus the 10. That was my answer. Y was equals to 83 over 2. Good. Now, let us go to the next question. Determine the value of y if AC is equals to 14 units. Okay. Obviously, what do we know? 14 units is the length of AC. Okay, the distance between point A and C, meaning this is taking us to the distance formula. Okay, and obviously we need to square both sides. Now let us look into that one. I started by writing down AC, which is 2, 3 minus 12y. Then I allocated coordinates of A as x1, y1, coordinates of C, x2, y2. Alright? Then, writing down my simplified form of the distance formula, AC squared equals to x2 minus x1, all squared, plus y2 minus y1, all squared. Substituting, then it was 14 squared equals to negative 12, negative 2, all squared, plus y minus 3 all squared. Okay. And then when you look at minus 12 minus 2 all squared, that is what? Minus 14 all squared. If I transpose it, I get minus 14 squared minus 14 squared, which is 0. Yes? Okay. Now, if I'm getting 0, this then means that I'm left with y minus 3 all squared equals to 0. You see, I wrote 2 the squared in blue to show you that if it's just 0, what do we know? I can put any numbers, you still get 0, except when you put 0 as an exponent. Okay, that will be undefined. But I said squared so that I can use my exponential laws. Okay, I usually do this when I only have 0. Please, if you have other numbers, that's why the square root is introduced and the plus minus needs to be there. Okay, but if it's 0, there's no use for saying plus or minus. Remember, 0 is neither positive nor negative, right? Now, equal exponents equal bases. Therefore, y minus 3 equals to 0. Those are bases. When I solved for y, I found that y was equal to 3. Okay, I think by now we have finished working with this example 4. Now, moving on, I want us to look into what we call collinear points. This is very simple. Just a fancy word meaning something very, very, very simple. What do we mean when we say points are collinear? Okay, this is when points lie on the same straight line. Look at what I've written down there. I have a straight line AD with points A, B, C, D. Alright, so what do we know? Since this is a straight line, and since we said steepness of a line doesn't change, it's a straight line, so its steepness will be constant. The gradient of any straight line remains unchanged. It remains constant. Then what does it mean? It means the gradient between AB, BC, CD, AC, BD, AD, it doesn't matter, will all be equal to one another. Why? Because this is a straight line. The gradient is the same everywhere. So if I am asking you to show that point A, B, C, D are collinear points, I'm just saying, show me by calculation that the gradient of AB is equal to the gradient of BC and is equal to the gradient of CD. Obviously, if you have shown me using calculations that those gradients are all equal, then you can conclude now to say, therefore, point A, B, C, and D are collinear points because all gradients are the same. Okay, that is all about collinear points. Moving on, this is how we write it mathematically. Small MAB equals to small MBC equals to small MAD. All gradients are equal. Last point, midpoint. What's a midpoint? I think I've already spoken about this. This is a point halfway between two given points. If I have A and B at a certain distance from each other, then there's a point that is halfway between them, meaning from that point to A and from that point to B, giving you equal distance. Then we say that point is a midpoint. It's at the middle of A and B. Okay, so how do we find the coordinates of the midpoint of any 2 points given? Okay, I'm going to use M for midpoint, but look at that M. That M is a capital letter M. It's an uppercase M, not small letter m, like for gradient. Okay, so when you write, it's very important for you to show the marker whether this is small m or big M. And another thing, when we are calculating gradient, we say small m equals to. But when we are calculating the coordinates of the midpoint, we don't say big M equal to. We say big M, open your bracket, x1 plus x2 over 2. Then y1 plus y2 over 2. Close your bracket. This is a coordinate of the midpoint. We are finding the coordinates of the midpoint. We are not finding the gradient. Please note it down. Small m, gradient. Capital letter M, we are finding the coordinates of the midpoint. No equal to signs when we are calculating the midpoint of a line segment, but we open brackets, okay? And we write it in coordinate form. Now, that part x1 plus x2 over 2 represents what? Represents xm. What is xm? This is the x value of the midpoint. Okay, that's why I wrote it down. Xm is equals to x1 plus x2 over 2. Then that part for y1 plus y2 over 2 represents what? Represents the y coordinate of the midpoint. That's why I wrote ym equals to y1 plus y2 over 2. Well done. Now moving on. We want to look at an example. Example number 5. Remember, up to now we have covered the distance between 2 points. We have covered the gradient of a line, of a straight line. And now we are looking at the midpoint of a line segment. Okay, between 2 points. Now, example 5, determine the midpoint of line AB. Okay, so we have A and B at a certain distance, and there's a midpoint between them. If A is 5, 6, and B is the point minus 3, minus 2. Grade 10, what is the first thing that we do? We write down A and B so that we can allocate them. X1, Y1, X2, Y2. Okay, so my A takes X1, Y1, B takes X2, Y2. Okay, then because I'm finding the midpoint of line AB, what do I write? I write down my formula or the method. Big M, open your bracket, x1 plus x2 over 2, y1 plus y2 over 2, then substitute. What is your x1? 5. x2 minus 3. Look at what I've done. I've put small brackets around the minus 3. Okay, but the plus is still there because it is part of the formula. Okay, why do we put brackets? Because you will need to use your grade 8 operations multiplying a positive and a negative. That is all over 2. Then 6 plus minus 2 in brackets over 2. When you use your calculator, you don't even need a calculator. This will be 5 minus 2 over 2, which gives you 1. Then 6 minus 2 over 2, which gives you 2. So the midpoint of line AB will be 1, 2. Okay. Now, let us move on to slide 23. Another example. Okay. Remember, we are still dealing with midpoints of a line segment between 2 points. Example 6. Determine the coordinates of B. Okay. They didn't say B is the midpoint, but we are determining what? The coordinates of B. If A is the point 2, 7, and the coordinates of M, the midpoint of AB are 6, 4. So what is happening here? We have point A and point B at a certain distance, and between them we have the midpoint, which is M, and the coordinates of M is 6 and 4. So it's like now we know the coordinates of the midpoint M. Okay, then I added something there, little spice. Represent graphically. I want you to show me this. How will this line look like in a Cartesian plane and the point M? And I want to see whether the M will be halfway between A and B. Okay. Now, what do? Remember now, we can't write M bracket x1 plus x2 over 2, because we know what is M. But what do we do now? We split the formula into x part and y part because we know xm and ym. Yes? Good. Now, xm we said is equals to x1 plus x2 over 2, and then substituting there, what is the x coordinate of the midpoint? 6 equals to your x1 will be 2 plus xb. Where does 2 come from? This is the x coordinate of A. Alright? All over 2, because multiplying 6 times 2 is 12. Then transpose the 2, it will be minus 2. So 12 minus 2 is 10, meaning the x coordinate of B will be 10. Similarly, we do the same thing for the y coordinate of B. Okay, how do we do it? So we are going to say ym equals to y1 plus y2 all over 2. And what is our ym? Our ym is the coordinate, the y coordinate of the midpoint, which is 4, all equals to, what is y1? Y1 is the y coordinate of A, plus yb all over 2. So this will be 4 equals to 7 plus yb over 2. Finding yb, the answer is 1. Remember, we must write it in a coordinate form. B is 10 is to 1. Well done. So this is examinable, and we'll always get such questions around midpoints where you'll be given the midpoint and be asked to find the other coordinates of a certain point. Okay, so please practice this well and know it, because a question like this may come and you need to know how to do it. Okay, now moving on, slide 24, we are going to look now at equation of a straight line. What's an equation? An equation is a formula that defines a certain function. In this case, the function is a straight line. It's a linear function. Okay, so we want to look at how do we find a formula for any straight line, and we call it an equation of a straight line. We have two forms of an equation of a straight line. A, we have y equals to mx plus c, and we have y minus y1 equals to m x minus x1. Okay, you can use any of the two. You have to use one of the two. Okay, you choose which one you like, but it's best to know both of them because sometimes questions may force you to use a specific form from these two. Okay, now what is m? So m is what we've already covered, the gradient, the slope of a straight line. Okay, what is c? C, very important, please listen. Have you ever seen how a straight line looks like when you draw it in a Cartesian plane and where it cuts the y-axis? So where it cuts the y-axis, let's say I draw a straight line, then it cuts the y-axis at 5. So 5 will be my y-cut. What is the meaning of that? That's where the function cuts the y-axis. Okay, so we call it the y-cut, cutting the y-axis. Okay, so C is representing exactly that. It is the y-cut, or famously known as y-intercept, where it intercepts the y-axis. Okay, then what is x1 and y1 from the second form of the equation of a straight line? This represents a point that lies on the straight line. Okay, a point that is defined for the straight line. Now let's go to an example. Example 7. Determine the equation of a straight line. So what are we finding? Y is equals to mx plus c, which passes through the points A, 3, 4, and B, 5, 10. Remember, A and B will be at a certain distance between from each other, right? So it means when I use A and B, I can be able to find what? To find the gradient, right, of the straight line using A and B. So I start by writing down the form that I want to actually use. Y equals to mx plus c. What is m? Gradient. How do I find gradient? I use any 2 points that lie on the straight line, which is A and B. I allocate them as x1, y1, x2, y2. So the gradient of AB is equal to y2 minus y1 over x2 minus x1. And what is y2? 10 minus y1, 4 over x2, 5 minus x1, 3. The answer is 3. The gradient of that straight line will be 3. Okay. Now I have m. What do I need now? I need the value for c. How do I find c? Let us look at the next slide. So first I put in my gradient where there is m. Y equals to 3x plus c. So remember, A and B are points that lie on the straight line. So I can what? I can substitute either A or B in the equation for me to find C. So I said substitute A or B. I'm substituting A. You can substitute B. That's fine. So remember, 3 will be my X, and then 4 will be my Y. So when I substitute, 4 equals to 3 times 3 plus C. Therefore, my C equals to minus 5. Therefore, the full equation now will be Y equals to 3X minus 5. The minus 5 represents C. Or, those who are using the second form of the equation of a straight line will therefore say Y minus Y1 equals to MX minus X1. Substitute A or B again, we'll get the same answer. Okay, but here I decided to substitute B to show you that we are actually getting the same thing. So, what is my 5 and what is my 10? Here, 5 and 10 represents X1, Y1. So, Y minus, what is Y1? 10 equals to M is 3, which is the gradient. Then X minus, what is X1? 5. When I simplify, 3 times X, 3X, 3 times minus 5, minus 15. Transpose the minus 10, then it will be 10 minus 15. Therefore, 3X minus 5 will be equals to Y. Okay, that is how we find the equation of a straight line. Now, the next thing is example 8. Let us look at example 8. Determine the equation of the straight line which, so it's like we are finding the equation of a straight line given certain conditions. So the first condition is which is parallel, meaning that straight line is parallel to another line. Okay, and that line has the equation y equals to 2x plus 5, and the one that we are looking for passes through the point 4 is to 5, okay, which is point A. Now, what do we know? If the line that we are looking for and the line that is given are parallel, they have the same gradient, meaning we are still going to use that 2 because the gradients are equal. Okay, parallel lines have equal gradients. That's why you see me substituting a 2. So y minus y1 equals to mx minus x1 is the form of the equation of a straight line that I'm using. And substituting the gradient, I have y minus y1 equals to 2x minus x1. And then, remember, you need a point that lies on the straight line. And in this case, we are given that point A is the one that is lying on the straight line, which is 4 and 5. This will represent my x1, y1. So, y minus, what is y1? 5 equals to 2, all multiplied by x minus, what is x1? 4. Then 2 times x to x, 2 times minus 4, minus 8, transpose the minus 5, then I'm getting minus 3. Therefore, the equation of the line that you're looking for will be y equals to 2x minus 3. Well done. Let's go to B. Perpendicular. Okay, to the line. The line that you're looking for is perpendicular to this line with the equation y equals to 1 over 3x plus 5. And the one that we are looking for has a y-intercept of 9. Well done. What is the y-intercept representing in our case? It represents C, meaning we're done. C is 9. And then because this line that we are looking for and the line that is given are perpendicular each other, meaning what? Meaning their gradients will multiply and give us a minus 1. You remember? Okay, so I can first find the gradient of the line using the gradient of the given line. When I multiply them, the product gives me minus 1. Then I know the value of C, which is 9. Okay, but let us look into that one in terms of writing. So, perpendicular lines, what we know? Their gradients multiplied to minus 1. So, the gradient of the line that we are looking for, let's call it M1, multiplied by the gradient of the line that is given, let's call it M2, will be equals to minus 1. So, we are looking for M1. This will be multiplied by, what is the gradient of the given line? 1 over 3. And this will all be equals to minus 1. Then, how do you find M1? We divide both sides by 1 over 3. Or we multiply both sides by 3. And we are getting the answer, minus 3. This is what? The gradient of the straight line that we are looking for. What is C? C is 9. How do we know? It was given. Okay. Therefore, using this form of equation of a straight line, y equals to mx plus c, then I said y equals to, what is m? Minus 3. X, what is c? It's a positive 9, therefore plus 9. And that is the equation of what? Of the straight line perpendicular to the given other straight line, and this line passing through y-intercept 9. Okay. Now let us go to C. We are determining the equation of a straight line which is parallel to the x-axis. Parallel to the x-axis. What do we know? A line that is parallel to the x-axis will have its gradient being equal to 0 because there is no change in y. Remember? Parallel to the x-axis, gradient is equal to 0. Okay. If gradient is equal to 0, let us look at the work solution. Look at this. Line parallel x-axis, gradient equals to 0, m equals to 0. That means I'm left with y equals to c because mx is gone. So if I'm left with y equals to c, what do we know? We were told that this particular line we are looking for, the equation of the particular line that we're looking for, passes through the point 1, 4. Okay, so I'm going to substitute that as x and y. Then let's look at what we got. When I substituted the point 1, 4, remember I no longer have x, so I can't substitute 1 anyway, but I can substitute 4 because 4 represents y. Okay, so when I substituted 4 where there is y, then my c was equals to 4. Therefore, the equation of this straight line will be equals to y equals to 4. Okay, well done. Now, let's go to the last question, which is determine the equation of the straight line which is parallel to the y-axis. Parallel to the y-axis. What do we know? If a straight line is parallel to the y-axis, then it is perpendicular to the x-axis. And what do you know about the gradient of a line parallel to the y-axis? Its gradient is undefined. Okay, we said it. Its gradient will be undefined. There is somewhere where we said that and we wrote it down. Okay, please make sure that you go back to your notes. Okay, gradient of a vertical line is undefined. Good. Now, let us look at the equation. How do you find that equation? First of all, line parallel to y-axis, its gradient is undefined. Okay, I have drawn that line which passes through point 1, 4 as given in the statement, and I realized that my blue lines will be passing through x value 1. Okay, that means then its equation will just be x equals to 1 because we don't have the gradient here. So the gradient, the mx part is not there. And also, this is a constant function, meaning it is only passing through x equals to 1. Okay, because this is a parallel line to the y-axis. Well done. So the answer is x equals to 1. Now, let us go back to slide 23. So on my slide 23, there's a part that I skipped where I said represent graphically the midpoint. Okay, question. So I've done it here on slide 32. Okay, so this is my graphical representation of point A, M and B, where M was the midpoint of AB, and we're looking for AB. Okay, we're looking for point B. So that is the graphical representation. Now, next. Let us look at example 9. Okay, determine if triangle ABC with vertices ABC given is a right-angled triangle. Underline, is a right-angled triangle. Okay, so what do we know about the right-angled triangle? One of the angles of that triangle must be 90 degrees. Okay, must be 90 degrees, meaning two sides will be perpendicular to each other. I can use gradients, multiplying gradients of two lines, giving me -1. It means then they are perpendicular to each other, and therefore it will be a right-angled triangle. I can also use what we call theorem of Pythagoras. You remember, where we say the square of the hypotenuse side is equal to the sum of the squares of the other two sides. You remember? So let us look at how I have done it. Method number 1, I have actually found the length using distance formula of AB, of BC, and of AC. Please do the calculations. 1 mark formula, 1 mark substitution, and 1 mark for answer. So my distance of AB equals to 3√2. Then my distance of BC, the length of BC, square root 26. Then the length of AC, 2 square root 2. Okay, all units. Now, after I've done that, let us check. I've let my BC be my left hand side. Then I said, if that's my left hand side, let me square BC. So square root 26 all squared, the answer was 26. Then I said the sum of the squares of the other two sides, which is AB and AC, let them be my right hand side. So AB squared plus AC squared, which was 2 square root 2 all squared plus 3 square root 2 all squared. I also got the answer 26. What is this? I have used theorem of Pythagoras. Since my left hand side is equal to my right hand side, that means BC squared is equal to AB squared plus AC squared. What does it mean? It means triangle ABC is a right-angled triangle. Okay. I would also say the gradient of AB multiplied by the gradient of AC. And I noticed that when I multiply the two gradients, they are giving me -1. What can you tell? This then means that my angle A is a 90 degrees. Okay, please do that as method number 2. Okay, now let us look at a mixed exercise now. Example 10. Okay, example 10 says triangle PQR, okay, with vertices P, Q, and R is sketched below. Okay, I forgot to sketch it, but I hope there at home you are going to sketch it on a Cartesian plane, right? Please do that. Now, determine the coordinates of S and T. Okay, determine the coordinates of S and T if they are the midpoints of PQ and PR respectively. Pay attention to the word respectively. What does it mean? It means S is the midpoint of PQ and T is the midpoint of PR in that order. All right. So S is midpoint of PQ, meaning I'm going to use the coordinates of P and Q to find S as the midpoint. Therefore, I found that S was 3 and 3. Okay. Then T being the midpoint of PR, I'm going to use the coordinates of P and R to find the coordinates of T as the midpoint. So T is midpoint of PR. Then I found that T was 6:2. Okay. Now B, show that the points P, T, and R are collinear. First, what do? I draw a small picture for myself so that I am not lost. I understand what the question is asking. PTR, if they are collinear, meaning they lie on the same straight line and they must have what? Equal gradients. Okay. So if PTR are collinear, the gradient of PT must be equal to the gradient of TR. I've used my gradient formula, y2 minus y1 over x2 minus x1. Then I substituted the coordinates of P and T. Then I find that my gradient for PT was -1. Similarly, my gradient for TR was -1. So, since the two gradients are equal, what can you conclude? Collinear points? Therefore, PT and R are collinear. Why? Because their gradients are equal. Gradient of PT equals to gradient of TR. Well done. Now, we are going to question 11. Example 11. Okay. What are they saying here? A square has vertices. Remember, vertices are corners of a shape. No? A square has vertices 5, 8, that is S, 6, 1, that is R, 9, 5, that is Q, and X, Y, that is E. A square. Quickly, let us revise. What do we know about a square? Okay, A square has all of its sides equal to each other. A square has corner angles each equal to 90 degrees. The diagonals of a square, what are diagonals? The lines that are drawn inside the square from one corner to the other corner. So the diagonals of a square bisect each other at 90 degrees, okay, and they will be equal in length, meaning the midpoint of diagonals will be the same midpoint. They will have the same midpoint, okay. The diagonals will have the same midpoint. Good. So in analytical geometry, what did I say when I opened this session? I said geometry is about shapes. So your quadrilaterals, your square, rectangle, parallelogram, rhombus, trapezium, your kite, etc., will be mixed into this topic. All right. So you need to be able to know the properties of those quadrilaterals. Okay. Now let's look at the question. Using the fact that the diagonals of a square bisect each other, determine the coordinates of E. Okay, so what have I done? Let us look at what I've done. I've said M is midpoint of SR. Okay, M is the midpoint of SR. They didn't give you M here, but I've used my small diagram. I've drawn my small square there, and then I said let M be the midpoint. Okay, so M is the midpoint of SR. Why do I say SR, not EQ? It's also true, M is the midpoint of EQ, but I'm saying SR because I know the coordinates of S and R, and I can find M. Okay, let's do that. So M, I found that M was 11 over 2 is to 9 over 2. Okay, using the midpoint formula. But how does this help us? Okay. But M is also the midpoint of QE. So using the coordinates of Q and E, where E is X and Y, I've now separated. Okay. Separated what? The X part and the Y part. And this will help me to find the coordinates of E. Okay. So XM equals to XQ plus XE over 2. Where xm is the x coordinate of the midpoint of M. That will be 11 over 2. Then the x coordinate of Q is 9 plus xe, which is the x coordinate of E, over 2. Then finding xe, I found that my x coordinate of E is equal to 2. Similarly, I found that my ye, using the same technique, was equals to 4. Therefore, my coordinates of E were then 2 is to 4. Well done. Now, let us look at B. Looking at B, they are saying if E is the point, 2 is to 4. All right? Which is what we have already found. Prove that the diagonals of a square are equal in length. So what are they saying? They just want you to show. Look at this diagram that I've drawn here. They want you to show that SR will be equal to QE. Those are diagonals, right? Those lines inside the shape from one corner to the other corner. Okay. So I've done that. I've calculated the length of SR using the distance formula, 1 mark formula, 1 mark substitution, 1 mark answer. Please do the calculation. Okay. So SR, I found that it was 5 root 2 units. Then QE, I also found that it was 5 root 2 units. Therefore, SR and QE are equal. What does that mean? I've answered the question. The diagonals of a square are equal in length. All right, you need to write that conclusion. It's very important. All right. Now, let us look at the last exam question from GBE November 2015, paper 2. Okay. Now, that was a question 3, and the total marks were 18 marks. Question 3, in the diagram, C is a point on the y-axis such that A, B, C, and D are vertices, are corners of parallelogram A, B, C, D. Remember, I said to you, you must revise all your quadrilaterals. Okay? And parallelogram is one of them. K is the point 0 minus 2 1 over 4, which is on the y-axis. And L is a point on line AB such that KL is parallel CB. If KL is parallel CB and CB is parallel AD, what do we know? AD is parallel, KL is parallel BC. So all those 3 lines will be parallel to one another. Okay? Good. Now they are saying calculate the length of diagonal DB. Remember, if I'm calculating the length of DB, I must use the coordinates of D and B. Do we have them? Yes. D minus 4, 2. B, 4 minus 4. So I've calculated. I start by writing them down, then allocate x1, y1, x2, y2. Then when I use my distance formula, I found that dB was 10 units. Well done. The next question is, calculate the coordinates of M. Do you see M in the diagram? No. But what do we know? M is assumed to be the midpoint of DB. Meaning I'm going to use the coordinates of D and B to find M. Okay. Then this is what I've done. I've substituted the values of D and B using the midpoint formula, and I found that M as the midpoint of DB had coordinates 0, minus 1. Okay. And then 3.3. Calculate the gradient of AD. Do we have the coordinates of A? Yes. Do we have the coordinates of D? Yes. So we can be able to find the gradient using the gradient formula. Okay. So I've written down A and D and allocated them as x1, y1, x2, y2. So the gradient of AD is equal to y2 minus y1 over x2 minus x1. Substituting, I found that the gradient of AD is half 1 over 2. Well done. Now, prove that 3.4, prove that AD is perpendicular to AB. What does it mean? Find the gradient of AD, find the gradient of AB, multiply them. If your answer is -1, then AD is perpendicular AB. Okay, let us look at that one. I have done it. What did I do? I've started by finding the gradient of AB. I write down A, I write down B, allocate them to x1, y1, then substitute. My answer for the gradient of AB was -2. But what was the gradient of AD? It was half from 3.3, right? Then I multiplied the two gradients, gradient of AD multiplied by gradient of AB, therefore half multiplied by -2, then my answer was a -1. Wow! Since I'm getting -1, what does it mean? It means AD is perpendicular to AB. Meaning which angle is 90? It's angle A. Try to sketch that and you will see. Okay, just draw two lines, make them to be perpendicular. You will see that angle A is the point of point of contact. Okay, it's the point of contact for the two lines AD and AB. Well done. Now, 3.5, give a reason why parallelogram ABCD is a rectangle. Tell us, why is that shape also a rectangle? When we started, they said it's a parallelogram, but now they are saying, why is it also a rectangle. Okay, now the reason is simple. It is a rectangle because, let us look at it, the parallelogram. Okay, guys, that symbol there, please don't be confused. This symbol here represents a parallelogram. If you like, you can write it in full. This is parallelogram. Okay, please. This is parallelogram. So the parallelogram has one interior. This stands for angle. Okay. This stands for angle. So this parallelogram has one angle equal to 90 degrees. What do you know about the rectangle? Also, rectangles have corner angles equal to 90 degrees. Okay. Please sketch down a rectangle. A rectangle will look like this. And we know that 1, 2, 3, 4. All these angles will be 90 degrees each. So since that parallelogram has one of its angles as 90 degrees, it means that's the reason why it is also true to say it's a rectangle. Okay, good. Now, 3.6, determine the equation of KL. Look at KL. We only know K. We don't know what the coordinates of L are. But what do we know about KL and AD? We said those lines are parallel, meaning the gradients of the two lines will be equal to each other. Okay, so the gradient of KL, look at what I've done. The gradient of KL will be equal to half, which was the gradient of AD, because KL is parallel to AD. Okay, that's good. So using my second form of an equation of a straight line, I said y minus y1 equals to m times x minus x1, where m is half. Then I substitute what? You don't just substitute any point. You substitute a point that lies on the straight line that you are being asked about. Okay. In this case, the straight line is KL, meaning I can only substitute a point for K or a point for L. So I have only K. That's why I said substitute K, which is 0 and minus 2, 1 over 4. And it was given as a result. Then I found that my equation is y equals to half x minus 9 over 4. Or those who are using the second, who are using the first form of an equation of a straight line, C, we already see it in the sketch. Look at K. K is on the y-axis, meaning it's the y-cut of that straight line KL, and therefore the y-cut will be negative 2, 1 over 4. So when I use the first form of the equation of a straight line, then y is equals to m is still half x, then c is minus 2, 1 over 4. And therefore, you can also write it as a minus 9 over 4. But those two mean one and the same thing. They're exactly the same. Okay. Now, the next thing is write down with reasons the coordinate of C. Okay. Look at C. C is on the y-axis, meaning the x value will just be 0 because all x values on the y-axis are 0. Okay. Now, how do you find C? Okay, there's a number of ways you can find C. Remember, M was the midpoint of DB, but also M is the midpoint of AC. I can use that, okay, where I will separate the parts to X part and Y part, and we know what to do. Or the other thing was, we found that diagonal DB was 10 units, but the coordinate of A is 0 and 4, meaning from the origin to A is 4. So what do I know about DB and AC? They will be equal. Diagonals of a parallelogram are equal, of a rectangle are equal. All right. So if AC is 10 and A and from the origin is 4, then I can say what? I can say 4 minus 10, and that will give me a minus 6, which will be the Y coordinate of C. Okay, let us write it down so that you can see what is it that we are saying. So this is what I have done. I've said M was the midpoint of AC, okay, where C has its x value equals to 0. So when I separated using the midpoint formula, I'm only focusing on the y part because I already know my x coordinate for C is 0. So I found that ym, which is the coordinate of y coordinate of the midpoint M, is -1. We calculated before up the, okay, and I think we also see it here. All right, is equals to, what is the y coordinate of A? 4 plus y coordinate of C over 2. Then finding yc, my answer was equals to -6. Therefore, C is 0 and -6. Where does the 0 come from? Remember, C lies on the y-axis, so the x value is 0. Okay. Or the other thing that I said you can use was to say ACDB. Let us look into that one. ACDB are equal in length, and both of them are equal to 10 units. Okay. What is happening then? If AC and DB are equal, then I said diagonals of a rectangle are equal. If they are equal, what does that mean? It means 4 minus YC will be equals to 10, and therefore solving for YC, the answer will be -6. So let us quickly go back to the sketch and let me show you how I've done that. We've actually said, okay, if you remember, this length, the length of DB, DB is 10, okay, but also the length of AC is 10. Why are they both 10? Because diagonals of a rectangle are equal. If they are equal, then from origin to A, what is the value there? We said the value is 4 units. Okay, so it will be 4. So it will be AC. Let us write it down. It will be AC equals to. Remember, what is AC? AC will be from origin to point A, which is 4. Okay, and then from C to origin, what will be? Remember, we don't know, right? But that will represent the value of C. That will be plus YC. But what do we know? We know that AC is 10. 10 equals to 4 plus Y coordinate of C. Therefore, that's how we found that YC was actually a minus 6. Okay. Actually, what we've done here, the plus YC is supposed to be negative because already we see that the Y coordinate of C is negative, and therefore coming here, this should actually be a negative. Okay, that will be your negative, and as a result, that's why we got a -6. Okay. Now the next thing is, let us look into, okay, I think this is what we've done. The other thing that we can do, we would use the gradient. Gradient of BC and AD will be equal to half because those sides of a rectangle are parallel, and therefore we would also find the coordinates of C. So you can choose one of the 3 methods and see which one is quite easy for you to do. Okay. Now last slide is additional notes. Okay, this is a nice thing, very nice. I want you to learn and know it by heart. When we deal with straight lines, shape is very, very important. Okay, the shape of a straight line is very, very important. Okay, so what determines the shape of a straight line? It is the gradient of a line. Okay, if the gradient is positive of a straight line, then the shape of the straight line will look like this one. Okay, it will look like that. Okay, and we say the graph or the function is increasing. Okay, but if the gradient is negative, then the shape of a straight line will look like this one, and we say the function is decreasing. So on a Cartesian plane, an example will look like this for a positive gradient, okay, and then for a negative gradient, we'll get something like this. These are just additional notes. Thank you very much, and I'm hoping that you will go through all of these notes and practice more and more problems. Remember, practice makes perfect. Okay, thank you. Sharp.